I'm just really here to introduce the two main speakers, but to have a quick look at the far more knowledgeable on embodied carbon than what I could ever be. So just to give you a little bit of an overview of what it means to STICO, though, the title of the seminar is rather long, but what we need to do is use increased numbers of bio-based materials such as timber, hemp, straw, cork, and STICO are a producer of the timber-based materials, structural and insulated products. So for us that means that we use 100% sustainably sourced timber, and we use 100% of that timber to make sure we get complete utilization of the product and what we're doing. All bio-based materials generally have low embodied carbon as a rule and act as a good carbon store. Quick example of this is a project we were involved with at COP26 back in 2021 with Roderick James Architects under the banner of Beyond Zero Homes, which was a combination of like-minded companies that came together to build a low-carbon house. So working together with circular energy, we were able to show that incorporating timber products in walls, roofs, floors helped to reduce the embodied carbon in the building by 22%. Sorry, should have jumped that one forward. Which is better, which has exceeded even the most stringent targets set out in the REBA 2030 challenge. What this highlights is that what we really don't need to do, we don't need to wait for things to come along. We're already there. We're able to do it based on bio-based materials back in 2021. So if we built from this level, from this base, think of what we could actually achieve by 2030. So as well as the reducing the embodied carbon, we were able to quantify exactly how much biogenic carbon we were storing within the building fabric. Now this means we can actively design our buildings to act as a huge carbon store and hence help mitigate the risks against long-term climate change. So if you have any questions, we're behind you there on stand E40. There's some really knowledgeable guys at the back there who are waiting and eager to take any questions you have, and obviously we'll have a Q&A session at the end of the talks. So without any further ado, I'd like to introduce Tabitha Binding, who is one of the most knowledgeable wood experts I've ever come across, so it's my pleasure.
Is this working? Yes? Oh, brilliant. Thank you, Craig. It's been such a pleasure to be asked by STICO to come and speak about specification and low-carbon natural materials. I've worked with STICO and Craig since the very first Trada University Challenge, where we were getting interdisciplinary students to work together to understand more about timber and more about natural buildings and materials. So this was put together back in December, but I'm currently on sabbatical. And I wanted to talk mainly about small projects because Christian will talk about large projects. So is anybody looking at small projects? Like small, so less than 100 square meters. Anybody looking at large? One. Anybody looking at large projects? Oh, there you go, Christian, you got more of them. But STICO's going to be happy either way. So if you've got a smartphone, the QR code will take you to this particular building. So this is Jeffrey Hart. So some of you might know him from Sustainable Buildings. He decided he was going to build his own tiny home, having spent time living on a canal boat. Now, a canal boat, obviously steel on water, lots of thermal bridging. Steel, natural material, I suppose, but not in the way we're thinking. So this is the journey he went on to build a tiny home that was good for not only his own mental health and well-being, but actually used natural materials. And he was building it to Passive House standards, so he wanted it to be airtight. But again, looking at low embodied carbon materials, you might see here, in this particular picture here, this is low carbon timber. Had he left the bark on, it would have been even lower. But literally, those logs there have been taken out of a forest as part of the management plans for that forest, and he's literally scraped the bark off. So it's come from a forest that he's actually living in. You probably can't get any lower carbon natural material than that. He's gone on to use ash flooring from a local sawmill. He was going to use, he has used some sheep's wool, but he has then gone on to use wood fibre bats in a timber frame. He's used cork insulation on the external, also on the internal. I'm never sure about using on the external, so it'll be interesting to see how that works. And he's achieved, I think, what he aimed to achieve. But his specification constraint over the natural materials and low embodied carbon was weight. And he wasn't able to quite achieve that. So the way he has managed to do that is to build a lot of the components in that he can take out. So he can remove the bed, he can remove the cooker, he can remove the fireplace. But again, he's used lots and lots of natural materials. This is a project I started working on, from actually 2010. This is the TENA system, and it is all about how do we get more Welsh timber growing in Wales, working with local manufacturers to build more and better homes from timber. The TENA system came into being around 2008. And at the top right there, you can see the very first TENAS building, TENAS house in one night, which has been completely built from Welsh Sitka spruce. The top right is where it was taken to America. It was packed into a shipping container, displayed there in 2009, 2010 in Washington. It then came back to Builth Wells and is on the Royal Agricultural Showground, which is the here. And so this was it at the beginning of 2015. We then managed to get Welsh Government and European funding to take it down and rebuild it. So by then we were looking at circular economy. Could you take this building apart? It's based on box beams, which have a European technical assessment on it. And this here is that building. The builders, you can imagine, they loved me. I said, no, we're not going to stick it in a skip. We're not going to sell it. We're actually going to take it apart. We're going to actually see, were there any problems? So there was a bit of water ingress down here. And we will shorten the sections and put it back together again. Next to it, there's a 70 square meters, 1.5-story home, which we put together in 12 weeks. Delivered, all from Welsh timber. Here you can see this is the box beam frame, manufactured, modern methods construction, off-site, 2 teams of builders, bit of personal information, probably going too far. This is where my marriage fell down. But then I wouldn't be here speaking to you today. So the box beams, Welsh timber, goes to one company, goes to a sawmill, is milled, is planed, is manufactured into box beams, then made into portal frames. During this time, there is shavings that come off them, so we use the shavings with concrete in woodcrete to add thermal mass to a lightweight building. It was monitored by Bath University, and again, these 1 and 2 inch slabs made a real difference. Here we're using end grain. Well, it's not end grain, actually, it's called, what the hell is it called? Slope of grain. So it's not completely end grain, and it's not completely cross grain, it's in between, so you're cutting it on the diagonal. Now, it's a really, really lovely product. The cladding is larch and a western red cedar. Now, we couldn't get enough western red cedar, so we had to get some larch as well. Specification, making sure you've got enough of material, making sure you're ordering it in time. I was working with, what's the name? Like there was a sawmiller, and there was the builder, and the builder needed to order it from the sawmiller. Now, there was a bit of miscommunication, and they just wouldn't get on and do it. So I went and had a quick chat with their wives and said, look, this is going to fail if we don't actually get it done. And they actually, kicked their husbands. So sometimes, working around people actually really works. And so we got it because we had 12 weeks to get this building up and done. It had to be opened in July when the Royal Welsh show went on. You can do your best with specification, and this here was meant to be all Douglas fir. And when I saw it on site, it was half larch, half Douglas fir. But it does its job. So even when you specify the right materials from the right people, it doesn't always come right. And just to finish up, this is my own personal retrofit. This is 1840s terrace home. I'm number 2 of 6. It is on the banks of the River Severn. It used to flood for the first 150 years of its life. So suddenly when I'm moving in 2015, 2016, it's like, what do I do with it? So here you can see where they've built the tarmac up around the outside. There's no damp-proof course. You talk to everybody, what do you do? I was like, not knowing Styco then, but I was really wanted to use wood fibre, which then I realised probably wouldn't be resilient if it floods again, which it will do. So take everything off, dig out the floor, take off the Carlite bonding, and then work with natural materials. Starting off with cork, so actually recycled expanded glass, foamed glass in the floor, 100 mil of limecrete on top, 40 mil of cork on that, 80 mil of cork on the walls after they've been parged with lime, and then lime hemp render on the top, or plastering, but wood fibre and sheep's wool up in the roof. Electric mat underfloor heating, 10 mil of natural slate, and double and triple glazing so that you get the heat coming in. That enables me on a 50 square metre home to on average use, this is whole house electric home, this year is 1,850 kilowatts in a year. That's and on average it's about 1,750, so that's 350 to 400 kilowatt hours per metre squared. So we know you can use natural materials, low embodied carbon, and you can get really, really good results. But that's, ask me some questions afterwards, and I'm going to hand over to Christian.
Thank you so much. My name's Christian Dimbleby. I'm from Archetype. As is mentioned before, I'm going to be talking about larger non-domestic buildings. So I've got 2 slides per page, which means I have to talk twice as quick. So I'm probably not going to cover in as great a detail, but please do feel free to ask me all sorts of questions afterwards. So the first project I want to talk about is Hackbridge Primary School. Here you can see the completed photos of it, the beautiful, lovely natural materials being offered, and the beautiful setting. This was an amazing client. They set an amazing brief. They wanted a one planet living building on the edge of the Greenbelt land. So it got planning permission on the condition that it was environmentally brilliant, basically. So it had to be Passive House Plus, the first net zero building, and we achieved all of that, even with a contractor going bust in the middle of it. So what is it? Well, I love this quote from one of the pupils trying to invite Prince Harry along. Our school is made of wood, and it totally is. So whether you go from the sweet chestnut exterior cladding, timber frame inside, the OSB Larson Truss walls, cellulose recycled newspaper insulation in between that. Then it's got wood fibre insulation on the outside of that. And on the internal cladding, you've got timber ceilings and lovely panelling in the entrance area, plywood panelling. Everything oozes natural, breathable timber, and the kids love that. They love the space, they love the light, they love the atmosphere that you get with low carbon natural materials. The only things that aren't are the foundations. We were next to a floodplain, so we have to have a concrete floor. It's really important that you don't put natural materials in flood areas, as Tabitha was saying. So we've got a concrete raft which has no floor finish on top of it. It's just a polished diamond ground concrete, and that's with a formwork of EPS insulation. The only other thing is the roof insulation, which is XPS. Ideally, we would have gone for natural materials, but the costs just weren't there to push that to the next stage. This is 10 years ago this was designed, so now we would be looking for cork or other natural materials to do that underneath the green roof. The only other final thing is that it has got one steel beam in it, but just one. But even so, if you look at the embodied carbon analysis, it's still not where we need it to be. The LETI target shows it only being a B or a C rating. Now, that partly is because it's only a small building, it's a small school. But we need to use all of these, and we need to use them better. We need to reduce our inputs, transportation and other factors so that we can really hit super low carbon, embodied carbon and operational carbon targets going forward. The next project I want to talk about is Harris Academy Sutton. It's the same client, actually, Sutton, London Borough of Sutton. This was started after the Hack Bridge, but finished beforehand because of the contractor going bust. And I moved across with the team of contractors who built this to complete the other one. With large-scale projects, you need to be thinking about different scales of economy, different speeds. So this is all a cross-laminated timber frame. You can see from the drawing here, it's cross-laminated timber floors, roofs, and internal walls, and then has glulam columns on the outside. We didn't need the structure there, so let's minimize it. And then it was just a timber infill build-up, along, again, with cellulose insulation on the inside of that. And, you know, that was really rapid, really quick to assemble. We detailed it correctly. The roof sloped so the water could come off. We put on temporary gutters. We got that waterproofing down. You can see the ground floor is concrete because the slope of the ground goes up by one whole story, so that's concrete. The CLT on site was catching up with the concrete works that were going on in the phased building. That's how quick it is. So natural materials, when people talk about cost, they may be marginally higher in cost, but actually if you're getting a benefit from speed, that can save you a fortune in your overheads of your building. So you really need to think about the whole holistic system and not just individual price of materials. This building, compared to a typical school building, concrete only, we estimated that we saved at least 20% of embodied carbon just from switching from concrete to timber. And that's without the fact that actually this building has no piled foundations. The only piled foundations on the site were for the crane base, and they were deep, and they were we had about 16 crane base foundations, and we had no foundation for the whole of the building that it was building. It's crazy. But again, this is beautiful atmosphere. The kids love it. It's being independently monitored to show how good that natural buildings can be compared to traditional buildings. Moving on, the third building I want to talk about is the Enterprise Centre at the University of East Anglia. I mean, this is just a magnificent demonstration of bio-based materials in every sense. The client brief was for that, and we won the competition based on achieving that goal. But it's still held up as an exemplar. This has been built 10 years ago. We were doing the design competition. It's been up for 8 years. Each of those 8 years having a DEC A rated. It is one of the best performing buildings in the country. And a lot of that is to do with high quality passive house performance, but a lot of that is to do with materials as well. The building does not overheat. I've got evidence from the staff that tell us that in the heat waves, the students come to this building, even though it's not cooled, to stay cool. I'll quickly move on to talk about what it's made of. So you've got yeoman wheat straw on the outside. You've got natural reed thatching. On the inside, you've got lots of materials: hemp, nettle fabric, Sonospray, cellulose, recycled insulation. If you want to find out more, that's on display on a panel at the UK Green Building Council stand just over there. I'm being told there's not much longer, so I'm going to go quickly on. The last one is another one also at the UK Green Building Council, the Entopia building. Retrofit is going to be the essential thing going forward. We need to retrofit 80% of our buildings. We need to deep green retrofit them to reduce their energy usage from typical buildings 300 down to about 50. And the only way you can safely do that is with natural materials. This building did it with diazothan, cork, lime render, and then wood fibre insulation on the inside. Again, the ceiling was coated with cellulose spray for acoustic performance and timber cladding. I'm going to hand over so we can have some Q&A questions now. Thank you.
So are there any questions from anyone in the audience? Oh, the front.
Hi there. I'm David from Architects Plus. It was really weird. I used to go to Hackbridge Primary School, just down the road from Bedshead. I was like, maybe there's another Hackbridge. It didn't look that green when I was there.
It's on the site just next to Bedshead. So the school you went on is in the corner, just around the corner. So the two schools work together. So this is a couple of the years operate in this building and a couple of years in the other one.
Right. I was looking for the enormous sheds at the back of... Yeah, that... Yeah. That's great. We work quite a bit in Sutton and Croydon, that kind of area. And Sutton Council declared a climate emergency a few years ago, upping all the standards, the 35% reduction in CO2. And we're working with other HAs in Sutton Housing Society for some of their quite small infill sites. Have you got any tips that you can share to try and make the small infill sites that have got to still look like the fairly boring brick houses that we're squeezing them into more green and sustainable?
I think, small buildings, it's essential that you choose the right materials, obviously. So, brick and block just isn't going to be the way forward. You can build, and there are lots of buildings around there that have been built out of timber. There's absolutely no reason why you wouldn't use timber-based systems. As Craig was saying earlier, you can hit those really super low carbon targets. You can build in lots of insulation. You can get that energy performance down. So, I just think holistically and just try and push for as much as you can, because Sutton are very enlightened clients and they really want to go further. So if you challenge them and say you can deliver this, they will encourage that.
Yeah, there's lots of timber-based systems out there, and it all depends on what you want to achieve. So I know Jay Cottrell's here over on the stand there, and she has the PH15 system, which is based on the Styco iJoist. But if you want to go solid timber, I can point you at manufacturers. If you want to go CLT, again, I can point you at manufacturers. But again, it's looking at what you want to achieve and how best to achieve it. So using the minimal amount of the right material for the right outcomes.
Hi there. When specifying low carbon materials or natural materials in general, who do you find provides the most resistance to actually getting them built with, and how can we leverage any good examples or previous precedents to kind of show that actually these natural materials can be used at small scale, but especially at large scale, especially thinking with fire and insurance or water concerns?
Yeah, I guess typically it's the builders who are, or the main contractors who are often hesitant of doing something with innovative systems or something different to their standard supply chains. So it's getting them on board. Once they're on board, there shouldn't be a problem. There is challenges with government changing regulations. We have to be careful of fire. That's really critical. But some of these products are still fireproof. Timber does very well. Cork is an extremely good product externally for fire resistance. It is I think the only product which is A1 rated non-combustible, so or A1 or A2. So there are ways of doing that, and natural materials can be used throughout different parts of the building. So it's just making sure the supply chain are on board and that you are demonstrating compliance to whatever regulations are required.
So, no, great question, because it has been problematic, and where there's been lots of pioneers, they have broken the ground. So if you want to go to Timber Development UK, there's lots and lots of case studies there. If you want to look at the Wood Awards, again, we've been doing a series called Design Timber, where you get the architect, the engineer, and often the client or the timber, installer actually, giving you examples. There's been lots of work done on fire. There's now a fire website, and then the ASBP have been working with insurance. So again, just reach out to the industry and all us people here who work in natural materials, and we will give you good, unbiased advice, and just come and ask.
Okay, next. Anyone else?
Hiya. I'm currently working on quite a high-rise building in London. I wondered, have you got any experience with height and working with these materials, and is there any limit, do you see, in including them?
Yeah, I mean, buildings high risks at height are problematic. So Archetype delivered a timber tower block for Swansea University, I think it was, 20 years ago, which was the highest timber building at the time. Then DRMM and others, I think, built much higher buildings following that as technologies improve. Obviously, the challenges are, we're going to have to follow what the requirements say. So if you're over 11 metres or if you're over 18 metres, you will need to follow those buildings. I'm not personally involved with many buildings that go up that high. Our schools and things are sort of maximum 3-4 stories. But at those levels, there's no reason why you couldn't have a lot of timber at the lower levels, and then where the high risk areas are, that be a concrete core or some other structure. So it's about using it in the right locations, and it may be that sometimes it's not appropriate to do higher level, but that doesn't mean that's only one element. The structure is only one thing, the facades are only one thing. There's all the internal floor finishes, there's all the ceiling finishes, there's all the internal wall insulations and other things like that where you can use low carbon materials. So if you can't use them because of certain regulations, try and use them in the other locations.
Hello, I live on a council estate. It has been facing demolition, and obviously now there's a possibility that it's retrofitted. And a big question I have is that if things are made of timber, I think traditionally things are made from a municipal point of view, things are made and not taken care of. So my question is about maintenance, and how can you incorporate like some sort of obligation that they're maintained to a certain, I'm just throwing it out there because almost you don't want timber because it's going to be rotten in a few years' time. I know that's really bad, but if you're not maintaining your property and you're in the hands of people who don't know how to maintain. So again, a general question about councils as well, about how much they understand. You said you had a very sympathetic council, but just generally, how do you feel?
Okay, I'll start. I think you just have to look at the historic churches. So many of those are made from timber. They are maintained. They have a requirement and a duty to do a survey every 5 years to ensure that they're maintaining them properly. The problem is current buildings are not maintained regardless of whether they're natural materials or not. The rack, all of these other things, people are taking short-sighted decisions and not doing maintenance and checking their buildings properly. So yes, it's particularly important for bio-based materials, but it's equally as important for all materials. So I would encourage all buildings to be maintained properly, and I think we do need to be better at handover documents, guidance for how the buildings are maintained, how they're checked. There's a lot more modern technology that can go in, so we put a lot of monitoring in our buildings. I'm just about to rush over to do a talk on monitoring buildings. We can actually insert them into our building structure when we're doing it. We can check the moisture levels, we can check the performance over time. So actually there's a lot more technology that we can do to reassure ourselves, and we do that as a process to help insurers to reduce costs and liabilities going forward, to make sure everybody's known. So whether that comes from a prefabricated system, you can check the delivery from the manufacturer to on-site to make sure it hasn't got damaged, hasn't got water ingress during the installation, because that can happen at the current time and is not monitored. But then you also need to do that in the longer term. So I think it's a tricky one, but we need to move forward.
Yeah, but then all buildings need maintenance, and all products have different maintenance requirements. Timber needs in general to keep it dry. Shed the water away from the building, and you have very few problems. But then it's also, when I say timber, it's, say if I said a vegetable and you're thinking of a pea and I'm thinking of a leek, like timber is literally the same. You could have a durable hardwood or a non-durable softwood. So again, it's understanding the right species and the right product for that particular situation. Now, I know in the 70s and 80s we had timber frame windows that just really didn't last. Whereas now, if you chose to use something like an Accoya, which is an acetylated timber for that window frame, it would be really fantastic. Now, Accoya comes from the sapwood of radiata pine, which is non-durable, and yet Accoya will give you a 60-year guarantee on that window frame. So again, it's picking the right materials for the right place, and actually having maintenance, in place. Because every time we go and replace something, that's adding to the carbon that we need to save, and not. Yeah. So again, it's getting the right people and understanding it.
Any further questions from the floor? No, that's it. Sorry, time. So I'd just like to thank Christian and Tabitha for taking the time to come and speak on behalf of wood fibre and natural building materials in general. Hope you've all taken away something useful from today, and see any questions any further. We're on the stand at the back at E40 there. Happy to take any further discussion you may have. Thank you very much.